World Spaceflight News Special Report.
So it turns out that Apollo fought through this as well. They had negative stress predictions for their flight. So these are excerpts from the final thermodynamics reports from the Apollo program in the late 60s. You can see the highlighted area on the top, structural analysis predict that cracking of the blader may occur. Wow. And then on the bottom, so what did they do about it, right? They went and decided and found, are cracks okay? And they did, right? Cracks predicted for the crew compartment will not produce structural overheating. So we think it might crack, but it's okay if it does. And so we went down that same path. We built test articles with cracks, in this case another ArcJet test article with a crack, tested them, measured how they performed, looked at all the data and said, you know what, yeah, Apollo, we're coming to the same conclusions that they did. If these cracks form, we'll be okay for the EFT-1 flight. So I've talked a bit about the problems on EFT-1. We've shown that Apollo had a lot of the similar problems. So this is the first little anecdote that I've come up with here based on this experience, Siren Song of Heritage. So Orion selected the Avcoat heat shield, the honeycomb gun Avcoat heat shield, primarily on a heritage argument. And I'll quote myself on the engineering definition of heritage. So it's a previous system that has been designed, fabricated, and operated very similarly to a proposed system. So something that's been done in the past that I'm going to do the same way in the future. And programs like this, organizations like this, right? Heritage systems make us feel good because it's been done before, so we can do it too. The problem is that heritage systems come with heritage policy and somebody else's risk appetite. What I mean by that is the program that implemented a certain solution in the past, you may build the same thing, but you may not have the same design rules that they did, or you may not be able to handle the same level of risk that they did. So Orion, we recognize the value of having a heritage system, but we didn't quite count the cost of the challenges that Apollo saw and that we found sort of in retrospect going through all this. Apollo documentation shows that they had cracks in their fabricated heat shields, particularly early on. On the Orion program, we went straight to the first full-scale article was the first article we were going to fly. That was the EFT-1 heat shield. Everything else to date was, up to that point, was small. So as Apollo built large-scale things, found cracks, worked around them, got them sorted out, and then went on to the flight articles, we went straight to the end because it was a heritage system, right? On the stress analysis side of the house, Apollo used some design policies that Orion has not allowed itself to use, frankly. And I'll talk about that a little bit in the past too. And that kind of got us into the pickle we were in with the negative margins and having to show cracks good in the same way that they did. But needless to say, the EFT-1 flight test was a success. So let's section to part 2 of the story, or 3, if you count the overview. So exploration flight test 1, December 5th, 2014, 2 orbits around the Earth, about a 4-hour duration. First orbit, very low orbit. Second orbit kicks out to almost 6,000 kilometers. To give you a sense of things, the International Space Station orbits at about 400 kilometers. So we're out at 6. The moon's at 384,000 kilometers, so we're not quite there. But we're quite higher than the typical low Earth orbits that you see. The reason we did this was to test one of the main reasons we did this was to test the thermal protection system, to test the heat shield. So we entered at about pushing 9 kilometers a second. Entries from LEO are about 7 kilometers per second. Entries from the moon may go a little north of 11 kilometers per second. Okay? So, and then the motivation for the title. So this is a video of the Orion capsule entering, taken from a DoD asset during the EFT-1 mission. So you've got the capsule there in the upper left. Acquire at Mach 22, 160,000 feet. We actually get good infrared imagery, and you can start to see features come out in the infrared because they're heating up at different temperatures because they're made of different materials. Those are the compression pads, or where the service module and the crew module are integrated together. And then we come down and splash down very nicely into the Pacific. We're about 200 miles west of the Baja Peninsula for this. So one of the important things about EFT-1, I mean, remember, this is the first ablative heat shield of this size that anybody's ever built, and certainly the first one that NASA's built in a long time. is we worked very closely with the recovery operations to make sure that the vehicle we got back was as pristine as possible so that we could do post-flight inspections, get all of our data off of it. For EFT-1, the U.S. Navy accomplished this recovery, Mobile Diving and Salvage Unit 11-7. So I worked with them very closely to talk about what parts of the vehicles are very important. Please don't touch them. Please don't touch these parts because it'll hurt you. You can touch these parts because they're not as interesting, all of that kind of thing. And they did a great job. We recovered onto the USS Anchorage, which is a landing assault ship that the Navy has. And you can kind of get a feel for how this worked from the picture in the lower right. These ships have a giant garage door, as it were, on the back. They can ballast down, flood an interior volume, and you can float things in and out, and then ballast the ship back up to pick up what you've recovered. And that's what we did. Floated the vehicle in, and then ballasted the ship up underneath it. And the heat shield did great. So this is one of the first images we got once it came back from a diver in the water before anyone else touched it. And we've got photo surveys that have happened almost at every point now since before flight to in the water to on the ship to back at KSC and so on and so on. So we can compare what's happened to it to make sure anything we see is because of the flight and not because of somebody dropped a hammer on it afterwards or someone nudged it or from recovery damage and all that. So we've been very careful about delineating all of that.